Russian Su-57 Felon has begun tests of new engine flat nozzles. A piece of information appeared in the Russian press about tests of a new version of the Su-57 multi-purpose combat aircraft, which received a sixth-generation engine with a flat nozzle with a variable thrust vector. It is apparently the further development of the Is-Deli 30 inches or second-stage engine, which is to be equipped with some of the production aircraft of this type. The second-stage engine itself underwent flight tests from 2017-2018 on the Su-57. Information about their results was not published. Meanwhile, for the flat nozzle power plant, news publications cite a slide from the United Engine Corporation (UEC) presentation, which reports that under the sixth-generation engine NTRP, not only is flat nozzle development underway, but the creation of new high-performance bearings, ceramic turbine elements, advanced electrical systems. Also mentioned is the creation of a power plant with a three-circuit engine, which will allow a significant, up to 12.5% improvement in subsonic effective fuel efficiency. UEC gives another slide where the information is reported directly on the new nozzle. Up to 90% of the nozzle parts are made by additive technologies, i.e. printed on a special 3D printer. The following participate in the production cooperative under the project: ODKUMPOOKB in the name of Lyulka, Salyut, ODK Saturn, LMZ, NIID, SAT, CNEAT MASH. In the process of work, the following were created: a mock-up for the study of the used components, models for the study of gas dynamics, and a demonstrator nozzle. The tests were successfully conducted at Sagi, ITPE RAN. An image of a Su-57 taking off with a new flat nozzle is shown. Let's add that serial production of the Su-57 continues under a government contract for 76 such aircraft. Russia already has about 20 series-produced aircraft put into operation. There are a dozen prototypes of the fighter, on which various technical solutions and new types of weapons are tested. Flat nozzles in fifth-generation stealth fighter jets offer several advantages over other types of nozzles. One of the main benefits is that they reduce the aircraft's infrared signature, i.e., the flat shape of the nozzle allows the hot exhaust gases to mix more evenly with the cooler surrounding air, which reduces the temperature of the exhaust gas and makes it less visible to infrared sensors. This is a crucial advantage for stealth aircraft as it helps reduce their detectability by enemy sensors. Another advantage of flat nozzles is that they provide better control over the direction of exhaust gas flow. In this way, a more precise and targeted control of the exhaust gases is achieved, which can be used to improve the maneuverability of the aircraft and reduce its radar cross-section. Another advantage is that this technology allows for more efficient expansion of the exhaust gases, resulting in more thrust and better fuel efficiency. Finally, flat nozzles are also more durable and reliable than other types of nozzles. This is because the flat shape of the nozzle reduces stress on the nozzle walls and minimizes the risk of cracking or deformation. Compared to other engine nozzle designs, flat engine nozzles are generally considered the most effective for combat situations, while other designs, such as circular nozzles or convergent-divergent nozzles, may provide some maneuverability and performance advantages. Flat nozzles provide a greater range of motion and control, allowing pilots to make more precise and rapid movements in combat situations.